welcome. This is Safa. In this video, we're going to implement the sliding mode control law we derived in the last episode directly in MATLAB. We've walked through every step, simulate the response, and discuss what's happening in the system live. Okay, let's quickly recall the system we're controlling, a second order integrator. Our sliding surface is S equal E dot plus lambda E, and the control law includes two parts, the equivalent part and switching part. We'll now go step by step to implement this in MATLAB. We define our simulation time and desired trajectory. Here it's a simple sine wave. This will help us track the performance of the controller. We initialize the system state position and velocity and set controller gain. Lambda effect, convergence rate, and eta is the switching gain. Okay. Inside this loop, we calculate the tracking error, compute the sliding surface, and apply the control input based on our law. Then we use simple Euler integration to update the system state. Finally, we visualize the system response. Okay, run. The desired wheel's actual trajectory, the control effort, the tracking error over time. This gives us insight into how well the control performs. Okay, thanks for watching. This is Safa. We're learning together, one concept, one line of code at a time.